All right, so I want to firstly go over indices rules and Surds rules, right? Hopefully you all remember these things. So if I give you these rules, when you multiply the same base, what you do? Whenever you have the same base, what you divide in, what you do? If you have same base, well, sorry, not same base, but you have a to the m multiplied by a to the n. This will be what? You just multiply, right? One thing I want to point out here, right? I think we did it somewhere, or somebody did it. If you have a to the power 3 on 2, right? Or any function to the power 3 on 2. This is the same as writing a to the half all cubed. Correct? Or a cubed all to the half. That's okay? So there are two ways that you could write this. You could write the square root of a and a cube in it, or you could write the cube root of a and a square root in it. All right? Anyone can do it. Okay? It's important that you remember this because we were simplifying something. We had this issue. Anyway, probably unit 2 of somebody. Right, but just make sure you remember that. Anything to the power 0 is 1. So anything to the power 0 will always give you 1. If you have a to the power of m over n, right? That's kind of what we did here, right? It will be a to the 1 on n all by m. Or we could write it like this, the nth root of a to the power of m. So this rule, right, is the same as this rule technically. See enough? Right, the only thing that you have to identify here is what the n means. 1 on n means. Right? 1 on n means that. All right. So these are the rules that we need to remember for indices, right? Anybody have an idea of what does the indice graph look like? Like a to n power. All right, we'll look at it in a little while, right? Right, we'll look at it in a little while. Right. While we're here, we can bring up Surds. Right? While we are you're down all the time? Yeah, you know, come? Yeah. Oh. You're all the time. All right. So these are some of the indice rules that we need to remember. And we can jump into the Surds rules one time. Right? Same thing here. If I give you the square root of a and you multiply by the square root of a, same base. Square root means to the power of a half. So a half and a half is simply 1, right? So root a by root a is a. Okay? What about if you had root a multiplied by root b? That will be root ab, right? You can root the whole thing and multiply the a by the b. Right? That's 1, 2. Next thing we need to remember, suppose I gave you root a, or suppose I gave you a over root a. What you'll get? A no, but let's simplify even easier. And a is what? A is what? A is root a by root a all over root a. So the answer is root a, right? That's okay. No rationalizing as you're coming to that. What is root a minus root b by root a plus root b? Work it out. Work it out fast. A minus. Work it out fast. Right, so what you'll get, root A by root A is root B by root B as B. Or you can just use difference of two squares, right? And work it out. Right? So this is used for if you have something like this, right? A plus root B over C minus root B. How do you simplify rational fractions? So to simplify it, what you want to do is you want to rationalize it, which means we're going to find a way to turn this third part into something rational. Okay? So you multiply by conjugate of this. So whatever sign you have in the middle here, change it. Negative becomes plus. All right? So during this process of going from this fraction, right, we do something called rationalization. What I will do is when you multiply the denominators by the conjugate of itself, right, this will now become a real number like this. All right? So what you're really doing in the denominator is you're making it real. Right? Look at the denominator. The denominator C minus root D, C plus root D is what? It will be C by C, which is minus root D by root D, which is D. That's okay? So it's always this squared minus this squared. That's okay? And this is something real. Okay? No, have no more surds again. Right? And then the numerator, well, we had to work out that, right? Right? So we'll try an example then. Right? All of this should be familiar from advanced, but we'll practice out some, right? If you didn't do advanced, well, you can sign up with. If you didn't do advanced, what I'll make you do is proof of that. All right, so we want to simplify this here. How you will simplify this fraction? Multiply by the conjugate of the denominator. So you're multiplying the numerator by the conjugate and the denominator by the conjugate. Right? So you're multiplying the numerator and denominator by the conjugate of the denominator. Move it up back. Let's see what they got. Thank you. This already. Huh? Like we got that quick. So we have Right? Check the answer calculations just to make sure, right? But you have right on charge of one. You can see on the board. What is it? Well, sit on the top. If it's up close, can you think faster, boy? Right? Let's see what you got. Right, so you're multiplying root 3 by root 3, that's 3. Root 3 by root 2, that's positive root 6. Root 2 by root 3, that's positive root 6 again. Root 2 by root 2, that's 2. All over. Right, no need to multiply it out. It's a conjugate, so it's root 3 squared, which is 3. Root 2 squared, which is 2. Right, so that's over 1, right? 3 plus 2 is 5. Plus root 6, that's 2 root 6. 3 minus 2 is 1. Right, so you can put it over 1. Huh? Say that again? Root 2 by root 3. What's up? So that's 2 root 6. Let's do one more. Let's do our next one, right? Three root 5. Three root 5 plus 2 root 3. All over 2 root 5. Minus 4 root 3. Take your time when you multiply this out. If you confuse the formula. The ratio is one board. Okay, wait. What? Why should we? let's pass now. Let's just put a name up here. That's the name alone, right? Look how this right, so multiply by 2 root 5, right? Conjugate of this, right? Are I get you?
Yes.
Yeah? No?
Yeah.
Who have you listening? Right, how this looks. Right, let me just remind you something. Remind you of something. If you're multiplying 3 root 5 by 2 root 5, 3 by 2 is 6, root 5 by root 5 is 5. So the answer is 30. All right? So when you're multiplying something like this, don't multiply 3 by this and 3 by this. Huh? This is 3 by 2, which is 6, root 5 by root 5, which is 5. Yeah. Right, so 3 by 3, that's 6. Root 5 by root 5, that's 5. 3 by 4, that's 12. Root 5 by root 3 is root 15. 2 by 2 is 4. Root 3 by root 5 is root 15. 2 by 2 is 2 by 4 is 8. Root 3 by root 3 is 3. And the denominator is just 2 root 5 squared. 2 root 5 squared minus 4 root 3 squared. The numerator is what? 30 plus 24. That's 54. 12 plus 4, that's 16. Okay? All over. 2 root 5 squared. 2 squared is 4. 4 by 5 is 2 squared is 4 squared is 16. 16 by 3 is
28.
right? So when you minus it off, it will be 54 over 20 minus this. Minus 16 over 28 root 20. Right? So I just divide both of them by minus 28. Huh? What's that? Yeah, I can reduce it. How much is that? Minus
27 plus 8.
here is minus 27 over 14. And here is
8.
all right, 9. Okay, so that's just it. Let's check out the next one. One a little bit longer. It's a past paper actually. Any questions online? Any questions online for this? It's a past paper, right? This is 2008. And that was number 1B. I cannot change it. So I want to add this to this. Right? Anything you want to do. So can we leave the answers here? Yeah, you can leave that. You can leave it like that. Ariana. Ariana. That is here. Right, so tell me what it says. So the name there. Everybody name it? I don't know why I can use it. What's up? And it's up to you, right? You can go them separately, then add it, or you can do it all together at once. Anyone you like. Right, but when you get message answers, Any answers? You work it out, right? No calculator. Yeah, you need to check it. You're supposed to get a nice whole number, right? Hey, look at smile. I thought your wife doesn't on Friday. Wasn't here. I don't know what that problem. I gotta go on. Yeah. Yeah. Any more answers online? Supposed to be a whole number. Alright, nice. Keep sending them. I'll give you 2 minutes again. Anybody confused? Anybody not getting a whole number? Okay, we shall fire it. Any question? Good. Okay, how much you guys given? All right, so let's take a look at it now. All right, so I will put all together, right? Right, I'm multiplying. I'm gonna find the LCM and work it out, right? So if I find the LCM, I'll get √6 minus √2, √6 plus √2. Right? When I multiply this by this will cancel, and I'll get √6 plus √2 by, and here I'll get √6 minus √2 by. Underneath here, you will get 6 minus 2. Here you will get √6 by √6, that's 6. √6 by √2, that's √12. What's √2 by √6, Shirish? So why right now? What's √2 by √6? What's √2 by √6? All these videos are available online. You can do online to make sure you understand why they're here. Tell me what you want to like. What you want to like. Focus on trying to catch the rules and what's going on. What is √2 by √6? √6 by √6 is 6. Right? √6 by √2 is what? So what is √2 by √6? What is √2 by √2? Right? Which is? Right? √6 by √6. right? To make sure you know what to do so you can try it, right? You don't want to spend time rushing on your notes stuff available online. Right? Try to do it. Try and do it before I do it, right? Root 6 by root 6 is 6. Root 6 by root 2 minus minus root 2 by root 6 minus root 12 minus by a minus is a plus. Root 2 by root 2 is where you leave out. What you do? This will cancel. 6 and 6 is 12 plus 4 is 16. Wait, no, say that one more time. So one option is to do it like this, right? Right.
Okay. Yeah, so like root 6 is not very you get 6 and then you get
no, but I'm wrong. Because the expansion for this is this. It just so happened that you got positive root 12 and negative root 12 and they cancel.
Yeah,
right? So if you expand this and you get 6 plus 2, that's a wrong expansion. Right? It just so happened that here also had negative root 12. So positive and negative cancel out. So you have to expand this like this, expand this like this. All right? So remember you're multiplying. So you're supposed to get your 4 terms that can simplify out, right? Okay, and when you work it out, you will get 4. Right? Good job, Ishmael. Who has sent some answers like Kalia, good, Eden, good, Sophie, you too, nice, Tavisha, and Naisha. Alright, so that's the way you work out your surds. There's one hard surd somewhere. Well, not hard, but some up to that. And then let's take a look at some indices, right? Actually, let me give you the indices one time. So we'll do some of these indices as well. You'd have done them in maths, but I wanted us to do some revision on that. All are given in our past paper, right? But there was a whole index that looked like this here. Right? I don't know why the iPad not connected. Anybody internet working?
Yeah.
You working good? I'm not connecting to the I'll show up. Anyway, I'll just write it. Any question online on this surd? Emily, any questions on this surds? No? All right. All right, so just try this last one. This last. I'm gonna just find back the indices. Right, they want in this year, this is 2005. Number 3, they want you to show quickly that root 11 plus root 7 is equal to 4 over. You have to show that. How are you doing that? Yeah, how you show the left hand side, you go to the right hand side. So you're going to work with the right hand side, is it? Yeah. So you can work with the right hand side, simplify, and it should become that. Yeah? Go ahead. Work with the right hand side, multiply by the what? Conjugate. What's the conjugate of this, Shavish? What's the conjugate of root 11 minus root 7? So what the answer will be? Shavish, what the answer will be? All right, hurry up, we'll get out fast. And come on the board. Okay. Right, if you guys go online, just message QED. It will come right to left. Right has more info. Right? So you take your right and go to the left. Oh, I wasn't mind. Oh, yeah, but no. Was it something?
Rises, you know, neighbor.
I would like you to try any question before I come on the board. Okay. Not wait till I write it down. Okay. So what's the multiply by here? Multiply by the conjugate of the denominator over itself, right? So that's root 11 plus root 7 all over root 11 plus root 7. When you multiply this denominator here, you will get 4, or sorry, the numerator will give you 4 by this. And the denominator is root 11 by 11, root 7 by root 7. All right, and that will give you, this is 4. So this will cancel with this and give you, right? And that is your left hand side. Yeah. All right, so that's technically what you're going to see in Surds, but you will see Surds more, right? You have to apply more Surds like when you're doing trig questions and simplifying it out. Right, you might just see one looking exactly like that. Right, let's try some indices. 2004 had one. Right, in 2004, the first part, which was easy, they wanted to show that 4 over 2 to the x is equal to 2 to the 2 minus x. Right? And then they want you to solve something after. Same question. They want you to solve 2 to the x plus 2 to the minus x is equal to 5. Anybody remember what they call these? What they call these here? In this guys, quadratics. So somehow this has to be a quadratic, right? Right. What's it? No. There's a proof. Show this equal to this. Take the left hand side and show the right hand side. Right, remember the group, so let's take the left hand side and make it look like the right hand side. Can't solve anything. I tried to help man. Yeah, but somebody else right? So you take the left hand side here, Shavish, and 4 is what? 4 is 2 squared, right? This symbol here means divide 2 to the x. Same base, division sign. So we minus. So you'll get 2 to the 2 minus x. That's all they want. Right? This one here is a little problem though. This one here, we have to find a way to convert it to a quadratic. Right? What does the minus sign mean again? We just prove it there, right? So this is 2 to the x plus 2 squared over 2 to the x. We're going to cross the 5. Right? This is confusion. So what to do? Leave it out. How you can do? Okay, yeah, you can multiply, or we can. This is looking kind of confusing, so we can let y. Let y equal to 2 to the power of x. Right? So we're going to get y plus 4 all over y minus 5 is 0. What's the next step? Multiply by y. So you'll get y squared plus, minus 5y plus 4. And we have our this guy quadratic. Okay, John, you see that? Or you just know when that this guy quadratic. You see in the indices and you end up with 1, 2, 3 terms. Once you see in those 3 terms, somehow or the other is a quadratic. You have to figure out what to make the substitution for. All right. Finish it up. Tell me what you get for x. Online are you okay? Let's know what we're going on there. Kyra, you good? Amanda? Eden? Eden still at this class? Somebody's trying to do class. Eden? I don't know. Next Eden, Mohammed. Yeah, that's solid quadratic. So what you got here? Y is 4. It's solid quadratic. And y is 1. Right? Y is really what? Y is really 2 to the power of x, right? So 2 to the power of x is 4. So we can solve this here. Right? 4 is really 2 squared x's. Right? And then you do the next one. 2 to the x is 1. 1 means what? 1 means 2 to the power of 0. Right, so your two answers are 0 and 2. That's your principle. Right? And you can just plug it in and just make sure. Right? Plug in the 0 and plug in the 2 and make sure you get in 5. Alright, let's go again. This one a little bit harder, but it's about being able to factorize properly. Alright? This one a little bit harder. Actually, that's the favorite. I'm gonna save that one. The last. Actually, no. I would like to end with a hard. I like to end with a hard question from party today. And I usually because people do really like to. Let's check out 2009, I think. Right, there's the next 2008. 2008 has two years. Without a calculator, evaluate this. 27 to the power 10 plus 9 to the power 10. All over 27 to the 4 plus 9 to the 11. Right? That's a 10, that's a 10, that's 4 and 11. Alright? Without a calculator, see if you can work this out. Right? The hint is to make sure you can factorize properly. Right, so you can behavior is you have to factor out something on the top and something underneath that will give you some calculation. So you have to figure out what to factorize that allows you to simplify it. Right, let me see if anybody gets already online. Not yet. Eden, where Eden Mohammed? Huh? Yeah, sir. Oh, yeah. Well, we're going to calculate. No, clear. She got to try. Okay, just clear. Yeah. Probably. Oh, what's done here. So look what's done here. Anybody get? You had 2 minutes again, so try something. Do that. Watch it, it doesn't matter because you're going to factorize the place out. Try something. Factor out something there. Right, and next thing I forgot to mention, I could also do a convert to the same base. Convert also to the same base. Okay, so 81. Right, so you convert them all to the base 3. Right, so that would be 27 is 3 cubed by 10. So that'll make it 30. 3 squared by 10. 3 squared by 10, so that'll make it 20. 3 cubed by, so 3 by 4, that'll make it 12. 3 squared here, 2 by 11 is 22. Right, what can we factorize out here? What you'll factorize out on top? Azaria said 3 to the 20 on top. And you will get 3 to the 10 here, plus 1. Right, this by this giving you this. This by this giving you this. And underneath factor out 3 to the what? 12. 3 to the 12 from this will give you 3 to the 1. 3 to the 12 from this will give you 3 to the 10. And we're good to go. What will happen here? These two are the same, right? Wait, someone wrong here. It should be 1. Right? These two are the same, so this will cancel. And you will end up with the square root of 3 to the 20 divided by 3 to the 12. Same base division. So we're going on minus. So that's 20 minus 12. So that's the square root of 3 to the power of 8. And we know that square root is to the power of a half. 8 by a half is 4. So the answer is 8. All right. So if you see a question like this, and it's not something that are general, you have to be able to do generally as well, right? Generally, to solve something like this, you have to find a way to factorize. If you have to simplify something like this, all you can do is to find a way and factorize something on top and something underneath. That would allow you to cancel and something. Yeah. Oh, I get 1. 3 to the 10 by 3 to the 20. Add the base and you get 30. 3 to the 20 by 1 and 3 to the 20. Right? You remember this by this have to give it a. Right? Let's go again. Any questions online? Someone quiet online. I hope you're trying it up. Right, good job. Aidan, Kishore. Did we share get you? Are you still playing games? Yeah, on the board. This one, yeah. On the board for this one, 2015. Right, 2015, number 2B. right? By just watching it, it looks like a what? This guy, right? Somebody had a yeah, okay. You got to figure out now what you're going to take is substitution, right? Yeah, we'll do that in that bracket. What you're going to let y equal. Correct. So for this substitution, make Rihanna. The screen looking blurry. Anybody else? Anybody here lucky? Right. So Rihanna said to let y equal to 9 to the. It's not working out. So if y is 9 to the x, what is y squared? 9 to the, which is the same as 81 to the x, right? So I can take off 9 to the x and I can write y. I can take off, I can take off 81. It's 4 and 4.
Yeah.
And I can take off 81 to the x and write y squared. Right? But it's fractions, right? So you don't want to work with fractions. So you multiply everything by y squared. So you'll get 3y squared minus 4y minus 4 is 0. Y is 2 and y is minus 2. Y is minus 2. But remember, y is really what? Y is really 9 to the x. Right. I want to point out something here. Could 9 to the x ever give you a negative value? Is there any x value that could ever give it us? No. So therefore, 9 to the x equals to minus 2/3 has no solution. That's okay? And anybody remember from mathematics how to solve this? Huh? No, I don't think that's it. Take logs. Right? Technically, I didn't show you that yet, but you should have known that from before. But you have to take logs here to solve questions like this. So you take log on both sides. So when you take logs, you'll get x is equal to log 2 over log 9. Right, but I'm not jumping into logs today. I want to focus on the exponential function. Right, online, you'll follow what I did. So I recognize that this guy quadratic. So I have to figure out what I am going to substitute. I look at this, and I look at this, and I said, okay, let's try y equal to 9 to the x. If you all convert to the base 3, there's nothing wrong with that. Right? You would have gotten 3 to the 2x, and here you would have gotten 3 to the 4x. So y would have been 3 to the 2x. Okay, and you'll get the same thing. So y is equal to 9 to the x. Y squared is equal to 9 to the 2x, or 81 to the x. Take off y and take off 9 to the x and put y, take off 81 to the x and put y squared, multiply by y squared, get quadratic and solve. All right. So here is something that I want to finish up the class with, right? We would like to try to get a sketch of that graph. Y is equal to a to the n. Right? If you want, we could use y is equal to 2 to the x to 1. It don't matter, right? They always have the same shape. Right. First thing first, right? If we had to sketch something like this, what's the first point we could use? X is what? X is 0. When x is 0, right? 2 to the 0 is 1, right? So when x is 0, y is 1. So it's passing through there. Right. Question. Is there any way I can make y negative? Is there any x value I can put here to make y negative? No. If I put -4 or -20 or negative a million, what you will get? You'll just get a fraction, right? Think about it. 2 to the -10. And that's 1 over 2 to the power of 10, which is a fraction. So is there any way this could be negative? There's no way for this graph to be down here. Right? So that graph doesn't exist in the negative part, and we saw that with that solution. There's no value for x that would allow us to give us a negative value. Are you okay with that? So whenever these values become negative, you're getting fractions, right? So you're getting small values. Could this ever be 0? Yeah. Could this ever be 0? Yes, really, when it's an infinity, right? But really and truly, no, it won't come. So all that will happen to this function as we use x negative values for x, it will come real close here. This fraction will get smaller and smaller, right? But it doesn't come to 0 unless it's infinite, right? That's the ideal case. Okay with that? So whenever x is less than 0, it looks like this. But when x is more than 0, how will it look? It'll keep getting bigger and bigger and bigger and bigger, right? So it will keep growing. So what you have there? That's it. That's the general graph for y is equal to h to the x. That's okay? All right, online. So this here is the general graph for y is equal to h to the x. If a is 1, it generally looks like this. If a is 2, it looks like this. If a is 3, it looks like this. Okay? And there's a special function. If a is equal to e to the power 1, that's the exponential function. Right? If a is equal to e to the power of 1, a, or just e, right? We have the famous exponential function. Right? We have the exponential function y is equal to e to the x. Let's see if we can figure this out. What do you think y to the x will look like? Same thing? Yeah. Same thing, Shavish? Oh, this look like? Same thing, Shavish. Very easy one. Right? So y equal to y equal to e to the x will look like that. And what you will recognize is the same way we solving this. Watch. Same way we solving this. The same way we solve functions with e. Same rules apply. Right? So like something like this, right? So for example, if I give you e to the x multiplied by e to the x, same base, add the powers. Same rules apply. Right? Same rules apply. If I give you e to the 2x divided by e to the 3x, same base, so you subtract powers. So everything you do with indices, everything, same thing you can do with the exponential function. Right? This is a special function because it could be applied to plenty of real life things, which I'll show you. When you all start doing modeling questions, this is one of the functions that you could use to model something with. All right, and we'll do some modeling functions next day and then do some, well, we'll do logs and then some modeling functions. Huh? Yeah. These are a couple of them. So you'll integrate this, you'll differentiate this, right, it's like a squeezing one. Time me out. Yeah. All right, so that's just, in fact, let's record that because I want to do logs before I show you. All right. Just do my quick favor and just squeeze in here the exponential function, right? Right. What you said. This line is on a asymptote, right? So this curve comes close there. Close there. Okay, so do like touch, right? So this is the function of that. Always remember that it cuts the y-axis at 1. Okay? Here then. All right, so that is your indices. That's your Surds. Next day we can do the log. All right, I just want to show you one thing, right? But sometimes I forget to do this version of it. Just one thing and we're done. So sometimes, like in 2015, same year, part C, they gave us a function, right? They gave us a function to model how bacteria are growing. Right? So bacteria, the population of bacteria present in a river, T hours represented by this. Right? So you would recognize that you're adding 300 onto exponential function. You're seeing that? I'll show you how to draw these things later on, right? But this exponential function, you're adding 300 on it. The first thing they ask us is, when T is 0, how much bacteria you have? What you'll do? Right, you just plug T is 0 in there, right? So you'll get 301. That's okay? That's the initial amount of bacteria. And they were able to use our exponential function to get us. That's okay? And just one more thing they ask you. They want the time to triple. Right? Time to triple number of bacteria. Kind of. What does triple mean? Triple means that the n value is now what? Right, 3 times 301, right? And you want to find the t value that'll give you this. So this is what? 900 and carry across 300 is equal to 5t. So this is 603 is equal to 5t. I just solve this. Take logs. Right? When you reach here, take logs on both sides. Okay? Right? I don't officially do logs, so I'll stop right here. Alright? Next week, I will start with reviewing logs and log. And you function called log. And then we'll do questions on this and do a couple more. Right, who do in module? You didn't have module 3? When that was When is the module 3? Somebody and when you're Friday. Huh? We do it module 1 and module part and module 2. Right, but I think we need to mount that with a platform. Again, who will module 2? If for the one Friday. Yeah. Yeah, it's have clean up. How about it?